Hi guys, we're back. It is section 2 of chapter 11, which is on mass and the mole. So last section we learned what a mole was. So now we're going to talk about how we can involve mass with the mole. Not too bad, but we'll work through it. So the first thing that we want to talk about is the mass. So last section we talked about how a mole is an amount of a substance. Well, moles can have different masses, just like compounds have different compositions. So think about, for example, 1 mole is just how many pieces of copper there are. So there's 6.02 times 10 to the 23rd atoms of copper. But 1 mole of carbon still has 6.02 times 10 to the 23rd atoms if I would piece them, but they have different masses. For example, think about if I had 1 dozen limes and 1 dozen eggs. There's still a dozen, there's still 12 of them, but they're going to weigh differently. So that's something that we want to think about. Their masses are not going to be the same, even though their amounts are. So one of the things that we use is called molar mass. A molar mass is the mass in grams of 1 mole of any substance. So molar mass is just that, the mass of a mole. It is equivalent, or it's the same as the atomic mass of something on the periodic table. So we can use the periodic table and we can look up the atomic mass, and that's going to be the molar mass. Its mass is in grams per mole. So the unit is grams per mole. How many grams are there in 1 mole? So what we do is we have to convert them. So if we go from moles to mass, we're going to start with number of moles, and we're going to take it times the molar mass, with moles on the bottom and grams on top, and it's going to end up with mass, which is measured in grams. So for example, if I have 3 moles of copper, I look up the molar mass on the periodic table for copper, and I find that it says that there are 63.546 grams of copper in every 1 mole. So if I multiply those, I end up with 191 grams of copper. So 3 moles of copper has a mass of 191 grams. So how would I then convert mass to moles with an inverse molar mass? If I'm going to go from molar mass to moles, now I can use inverse. How would I do that? Well, if the inverse is just going to flip. Okay, so we would just flip that around. I'm going to convert, and now instead, if I start with grams, and I want to end up with moles, my factor that I'm going to multiply by, what goes on the bottom? Grams, which is my molar mass, with 1 mole on the top, to where grams and grams disappear. So if I want to switch that around and go from mass to moles, all I do is use the inverse. And there's an example on page 316. We'll do some more and you have a worksheet with that, but there's some practice problems and some examples on page 316 that you can look at and you can work with Mrs. Gibson here in a little bit. Okay, well what if I want to convert moles to atoms? Okay, so now I start with moles, but I want to go to atoms. Well, this is just what we did last section. I'm going to use Avogadro's number. So I have 6.02 times 10 to the 23rd atoms on the top. Not very good with this. And 1 mole on the bottom, so that moles and moles cross out, and I'm left with atoms. So we're going to use that here in a second. We know this part from last section. We know that there too. Okay. So now, how do I go from mass to atoms? Okay, we're going to have one more step in there. I need to add another slide, it looks like. If I am going to go from mass to atoms, I start with mass and I want to go to atoms. Okay, so they're going to start me with grams. Let's say I have 10 grams of carbon, and I want to know how many atoms that is over here. Okay, I need to get there, but there's 2 steps. There is no conversion straight from grams to atoms. So I need to actually have 2 conversion factors in here. I need to have 2 conversion factors. The first one that I want to get rid of is grams. So where does grams need to go? It needs to go on the bottom so that I can get rid of it. And I can have 1 mole here. Well, I need to look up the molar mass, the number of grams per mole of carbon. So if I flip to my periodic table and I look up carbon, I can find that the molar mass of carbon is 12.011 grams per mole. Then I want to go to atoms. How do I go from moles to atoms? Well, moles, 1 mole, has to go on the bottom, and my conversion factor to atoms is Avogadro's number, 6.02 times 10 to the 23rd atoms. Okay, I multiply across the top. This is on the top. Multiply across the top, 10 times 1 times 10.02 times 10 to the 23rd. And I divide by what's on the bottom. So I made this one up, so let's find an answer. 10 times 6.02 times 10 to the 23rd divided by 12.011 gives me 5.01 times 10 to the 23rd atoms. Okay, so if I go from mass to atoms, I go from how many grams I have to atoms. I'm going to go from here to here. I can also go the other way. I just have to kind of follow the arrows. From particles, I start with particles, so I'm going to go this way. Particles then is going to go on the bottom, moles on the bottom to get to grams. And we'll do some practice with that here in 1 second. Okay, so check out these section check questions, and then we're going to do a little bit more practice. Let me see if I can come up with a new one. I don't see one. So what I want you to look at is I want you to look at the practice problems, okay, on page 318. You can work those out, but I want you, there's a worksheet, okay? Mrs. Gibson can hand out a worksheet when you guys are done, and I want you to do a couple, but probably go to the board and work some of them too, okay? Again, this is practice, okay? We will work some more when I get back, but I want you to practice them, okay? It's not too bad, but it is something that you do need to practice to get a foundation before, of course, we add more to it. Okay, we got to get the basics before we add more. Have a good weekend, and I will see you on Monday.